Okay, as we have two elements, you consider two force vector for the element 1, element 2. Okay, h value it is given T infinity. We know the T infinity in the problem. What is the T infinity value here? It is 40 degrees Celsius. So convert it to Kelvin. 40 plus 273. So it is 313. And the perimeter, already we have the radius. So by the radius you calculate perimeter, 2 pi r or pi into d. Okay, so it is 6.28 centimeters, and the length it is 2.5 centimeter divided by 2. Okay, as all the values are same for the force vector 1 and 2, for the element 1 and 2 you will get the same values again. Now you find the global force vector by adding the corresponding nodes. So adding the force vector at node 1 and 2, you have these values. Okay, now you use the equilibrium equation, that is kq equal to f, where q it is the nodal temperatures, or you can also consider T. Okay, what is k here? It is the sum of the global conduction matrix and global convection matrix. So it is the global stiffness matrix, and T is the nodal temperatures. For the three nodes we have three nodal temperatures, T1, T2, T3. Okay, these are the force vectors due to convection. In the fins, the main reason of the dissipation is convection. So for the convection force vector, you consider this equation h T infinity PL by 2. Okay, for the two elements you will get two force vectors, then you add these two force vectors to get the global force vector. Okay, this is the global force vector for this problem. Okay, now we have 3 by 3 matrix for the global force global stiffness matrix, and 3 nodal temperature and 3 force vectors. By this we can solve the nodal temperatures. By elimination approach method, we know the T1 value, that is it is specified temperature at node 1, 140 degrees Celsius. So first row and first column can be deleted. So you use your calculator either by matrix method or simultaneous equation to find the other two nodal temperatures. The answer you will get T2 equal to 353 kelvins and T3 is equal to 337 kelvins. Okay, let's see one more problem on this fins. Okay, in this problem you have to find the temperature distribution. Temperature distribution means it is, if you consider it as one element, then definitely there are two nodes. What are the nodes at what are the nodal temperatures at node 1 and 2? At node 1 it is 150 degrees Celsius. So what is the nodal temperature at node 2? Okay, here in this problem there is no convection heat transfer. Okay, it is the neglect convection heat transfer, it is given here. So there is no convection heat transfer, so do not find convection heat transfer matrix, and you have to assume the heat generated inside the fin, it is 500 watt per meter cube. So the force vector, instead of a force vector due to convection, now you will get a force vector due to heat generation. Okay, the formulae or the expressions or the matrix, it is not same for the force vector here. Now force vector it is due to heat generation. Okay, as there is no heat transfer from the convection, only you need to find heat transfer due to conduction. As you know, heat transfer due to conduction, you are using AK by L, 1 minus 1 minus 1 1. Okay, K value it is given or not. Okay, K value it is 6000 watt per meter Kelvin, and area value you can calculate it by the width and height of this cross section, 0.04 meters into 0.082 meters. Okay, multiplying these two dimensions you will get the area of the element, and L it is the length of the element. You can consider two elements or single element. If you consider two element, you find conduction matrix for both elements, then you find the global conductivity matrix. If you are considering it as a one element, then the same conduction matrix is the global matrix. Okay, let us find the global matrix or the conduction matrix for this element. K value it is given 6000, and area it is 8 into 10 raised to minus 5 minus 4, and length of the element it is 0.06 meters. So this is the conduction matrix, and now we know the equilibrium equation where it is kq is equal to f or kt is equal to f, where k is the global conduction matrix. It is already known value, and q value it is nodal temperatures T1 and T2, and f is equal to now force vector due to heat generation. For heat generation you use this expression AQL by 2. Okay, where A is the area of the element, Q is the heat generation rate, it is 500, it is given in the problem, and L is the length of the element 0.06. Okay, simplifying this or putting in this equation, that is KT equal to F, where K is the conduction matrix, T is the nodal temperatures, and force is, and it is force vector due to heat generation. Okay, so it is T1 and T2 value. Okay, let us see one more problem. Here also you need to find the temperature distribution, means nodal temperatures T1 and T2. T1 it is known value, so you need to find T2 in this problem. So what is the source of heat generation here? It is heat generation. Okay, it is 500 watt per meter cube. Again it is the same problem, but this time it is a hollow section, so you have to find the area by pi by 4 outside diameter square minus internal diameter square. Okay, let us consider it as one element. You find the conduction matrix. As there is no convection value is given here. Okay, let us see, is there any convection heat transfer coefficient? Okay, it is not a hollow section, it is insulated. So what you can inside this white colored, it is the body, and this is the insulation. Okay, so area is pi by 4 d square, it is diameter 0.02 square. It is, as it is insulated, insulated means there is no heat transfer to outside the environment, so there is no convection. If there is no convection, you need to find only conduction matrix. So K by L 1 minus 1 minus 1 1. So what is K value here? K value it is 400 meter per degree Celsius. So just you concentrate on this unit. 400. Area it is pi by 4 d square. Diameter is given, and the length of the element it is 0.09. Okay. So you will get a conduction matrix. Okay. Then you find a nodal temperatures by substituting this in the equilibrium equation. As the heat generation rate is given, AQL by 2 1 1. Okay, A value it is given, diameter is given, so you calculate area. Q value heat generation it is 500, and length it is 0.09. So only one element, so there is no need to find the global force vector. So KT is equal to F, put in this form and find the nodal temperatures. Okay, let us see one more problem. In this problem there is H value is given, so convection heat transfer will be there. K value is given, conduction value will be there. At node 1 it is 150 degrees Celsius. Okay, let us find the conduction matrix. AK by L 1 minus 1 minus 1 1. Okay, substitute the values and find the conduction matrix. As there is convection value is given, so the convection will be there, PHL by 6 2 1 1 2. Okay, just you add these two matrices to get the global stiffness matrix. Okay, as there is a convection, you need to find the force vector due to convection, that is S T infinity PL by 2, where H is the heat transfer coefficient, S T infinity is the outside environment temperature, that is given 50 degrees Celsius. Okay, parameter can be calculated by this 2 centimeter diameter, that is 2 pi r. Okay, so we'll get a stiffness matrix, and nodal temperatures are T1 and T2. Force vector it is given by this expressions. Okay, find the nodal temperatures, simplify it and find the nodal temperatures. Okay, thank you.